The first question in the Think About It shows us the equation of a parabola written in vertex form. We see this parabola right here, negative x plus 3 squared plus 4, shown to us in vertex form. That matches the graph that we see over here to the left. So notice that the vertex of this graph is at negative 3, 4, and we can see that the graph is concave down. It's opening downwards. So how does this connect the equation to the graph? Well, first of all, we can see that the numbers of the vertex show up in the vertex form equation for the letters h and k. So we can think about the vertex, negative 3, 4, as being a translation of 3 units left and 4 units up from our original vertex at 0, 0. The parent function for any quadratic equation, y equals x squared, has a vertex of 0, 0. And in order to get to this transformed equation, negative x plus 3 squared plus 4, we had to do a translation of 3 units to the left and 4 units up. So this brings us to our first key point for today, which is that translations of a parabola can be identified by the input and output of a vertex and is represented as hk in vertex form. Another way to think about this, instead of using the word input, we can use the word x. Instead of using the word output, we can use the word y. So the x and y value of the vertex in vertex form actually represent a translation of a parabola. Press pause to capture this in your notes. In addition to seeing that translation, we can also see that my parabola is concave down. That downward concavity connects to the a term of my parabola, my leading coefficient. So in my equation, I see this negative sign. This negative sign tells me that my parabola is opening downwards. So if we think about the parent function, y equals x squared, just a regular old quadratic, it is concave upwards. And in order to make it concave downward, we flip it over the x-axis. So this negative sign here, this negative a term, actually tells me that there has been a reflection. If there had been a number here as well, we would know that it was a reflection and a vertical stretch. That gives us our second key point. The vertical stretch and reflection transformations of a parabola can be identified by the a in vertex form. Remember that that a is the leading coefficient. Press pause and capture this in. We're going to skip debriefing the second part of the Think About It to save time, but here is our big idea for today, which is that vertex form f of x equals a times x minus h squared plus k allows us to see transformations in the quadratic function from its graph. So vertex form is going to be a really useful tool for us this year. Press pause to capture this in your notes. Let's head over to the I&M now. We have the graph of the function g of x shown here, and we would like to write the equation for h of x in standard form, so ax squared plus bx plus c, such that h of x is equal to g of x minus 3. I know this is a translation, and since it is outside of the parentheses here, it is a translation of the outputs, which is the y values, and since the sign is negative, we're going to be translating the outputs down by 3 units. So that's just something to think about in advance. So before I can translate the graph of g of x to get h of x, I actually need to write the equation for g of x. So when I look at this parabola, I know a couple of things about it right out of the gate. I know that its vertex is at 1, 2. I know that it has a y-intercept of 0, 2.5. I know it passes through the point negative 1, 4, and it passes through the point 3, 4. I also know that it is concave up, which means my a term is going to be positive. So I'm going to set up my vertex form equation and start filling it in. So I have g of x is going to be equal to a times x minus h squared plus k. That's just the parent formula for vertex form. I'll sub in my vertex, a times x minus 1 squared plus 2. So I look like I'm in vertex form, but I still haven't dealt with this a value. So the way I can deal with my a value is by picking any point on the graph other than the vertex. You could use the y-intercept, you could use this point, you could use this point. I'm going to use the point 3, 4. It does not matter which one you use. And I'm going to sub in the point 3, 4 to my equation. So 4 goes in for y, which is g of x, equals a times 3 minus 1 squared plus 2. I'm substituting my known information to be able to solve for the value of a. Let's make a note here so that we remember what we did. We substitute any point from the graph, just not the vertex, because we've already used the vertex. And then I can simplify. 4 equals 3 minus 1 is 2, so a times 2 squared plus 2. 4 equals 4a plus 2. And we're going to use this to solve for the value of a. And I end up with a is 2/4 or 1/2. So now I can put this a value back into my equation to get the equation of g of x. So g of x is equal to 1/2 times x minus 1 squared plus 2. So that equation represents what I have up in my parabola here. 1/2 times x minus 1 squared plus 2. But the question does not ask me for the equation of g of x. It asks me for the equation of h of x. And I know that h of x is the equation of g of x after a translation of 3 units downward. So I need to take this whole equation and I need to subtract 3 from the outputs to get h of x. So, get myself a little more paper here. I know that h of x has to be 1/2 times x minus 1 squared plus 2 minus 3. I'm subtracting that 3 just like the problem tells me to. I can simplify. 1/2 times x minus 1 squared minus 1. This question asks me to be in standard form. So this is a beautiful translated version of vertex form, but I need to be in standard form. So h of x equals 1/2 x minus 1 squared minus 1. I now need to distribute this term in the center. 1/2 times x minus 1 times x minus 1 minus 1. Excuse the phone ringing. I can then distribute my binomials here. I'm going to keep the half out front for now. This becomes x squared minus x plus 1. Combine my like terms. Notice that I have not touched the 1/2 or the minus 1 yet. Now I can distribute my 1/2, so I end up with 1/2 x squared minus x plus 1/2 minus 1, and h of x equals 1/2 x squared minus x plus 1/2 minus 1 is equal to minus 1/2. So that is my final equation for h of x.